file. Okay, if we look at it in the disassembly, we'll see exactly where we left off in the top window. And I'll start the encoder, which is also our decoder. So we've moved the starting point of our encoding address to EAX. We saw the content, so look at this area here. See that byte changed. We're increasing EAX. We're comparing it to the last section that we want to encode to. Since it hasn't arrived, we're jumping back to the SOR loop, and this is going to continue. And you can actually see the file being encoded as we speak. So obviously, I won't do this manually. I'll just put a breakpoint here. And when I let Ollie run, you'll just see all of this change really, really quickly. There you go. So basically what we have now is a file which has a stub and garbage in the data section. Okay? What I need to do now is take a snapshot of this file as is and save it to disk. And the next time that this file will be run, the same stub will run the same XOR loop on all the data section and will actually bring it back to the original file contents. But this will happen in memory and not in disk. So the antivirus will actually have nothing to say about this. Okay, let's try this. This is actually the annoying bit. Let me make sure I don't make any mistakes here. All right, so I'll be saving. Notice that all the commands are really gibberish now. They do not resemble anything that we've seen before. And what I'm going to do now, and this is a bit tedious, I have to actually select the whole data section to copy and paste it. I can't actually press Control-A. So I sort of have to think of something to say to entertain you while this happens. So Chris, go ahead. Nothing? Save me!
Take your top off.
Was that relic? Was that relic? Or was that zero chaos?
Zero chaos, and you didn't even see him.
Yeah. Too short. If it was relic, you'd be like, no, that's fine. Thanks, relic.
All right. So this is the end of our file. I'll just make sure I save all of this. Copy to executable, and we'll save this to number 3. So once again, this file on disk, at least the data section, is garbage. But once we run this, execution flow will be redirected to our stub. Our stub will decode the encoded data section and then execute normally in memory, hopefully. Let's double click this and see if we actually get a shell on port 99. Please don't crash. No, wrong one. Wrong one, thank you. Looks promising. Oops. All right, so the file is actually functional. Question is, not yet, thank you, not yet. I told him, listen, you got to support me when I go up there. You got to clap, but you have to clap at the right moment. So, thanks anyway, okay? Okay, so the big question is, what will happen now? Alrighty, okay? All right, so that's quite nice, and I actually have an excellent slide here.
Just made half the room's job harder.
Thank you, thank you, thank you. Are we good with time?
You are great with time.
Okay. So, second demonstration, ADD sucks. It does, because I made this demonstration and I couldn't find it for like 2 hours on my hard disk. Okay, so the next demonstration is an awesome demonstration, which I really, really love. And this is actually in reenactment of the MS-07017 vulnerability, the infamous Annie exploit thing. But there's an interesting angle. There's an interesting angle when you try to exploit this on Windows Vista. And this is what I'd like to do now. So you've got all the determiner vulnerability reports. There's sort of like the basic stuff is over there. I've actually got the vulnerability report itself. It's an interesting read. If this interests you, then take a look at it. And they've got a really, really interesting write-up about it. So the day this came out, well, not the day actually, it was like a couple of weeks later, I was looking at it, and they've actually got a proof of concept here, which shows the file structure which will trigger the overflow. So we'll be copying this, and we'll be working on the POC, and we'll be trying to get a bind or reverse shell. It doesn't really matter. As long as we get some sort of code execution, then we've done our part. If you want to put evil shellcode in, go ahead. Now, obviously, this thing has been patched since 2007. When was it? August? But again, the exploitation process is astounding, in my opinion. The whole process of bypassing ASLR was just brilliant. So this is what I'd like to show you now. To save some time, I've created my Annie files ahead of time, just so I won't have to mess around with Notepad too much. And basically, what we have here... Wow, I'm freezing. Excuse me. Basically, what we have here is an Annie file, which has got the exact same structure as our proof of concept. Let me just verify this. Yeah. So we quickly build an HTML file, which we'll call this malicious Annie file. Let me just make sure that everything's good to go here, because obviously 3 seconds before the demonstration, everything crapped up on me. All right. So if we double-click this, we can close this, and we can close this. If we double-click our proof of concept, and shove it under Ollie, and then refresh this page, we'll actually see that we've got a wonderful EIP overwrite. And basically taking this a step further and getting code execution on Windows XP or Windows 2000 is pretty trivial. But in Windows Vista, you've got ASLR taking control of the whole situation. And basically what that means is that we can't actually jump to somewhere in our buffer, to jump ESP or somewhere, because the base address of all the core DLLs in Windows Vista will change after each reboot. I think I have a let me just see. Yeah. Okay, so this is a demonstration. I actually rebooted Vista between the first screenshot and the second screenshot, and I looked at the same code in NTDLL. And what you'll see here is that at the first reboot, this code was at 776516A1. And on the second reboot, it was at a slightly different address. So this is what ASLR actually does. It randomizes the base addresses of the DLLs.